Hi students, in this video I will show you how to use the p-value approach or method to test your hypothesis. This is question number 4 from homework number 13. The question says you wish to test the following claim in the alternative hypothesis, and that claim is that the proportion is significantly different from the proportion presented in the null hypothesis at a significance level of alpha is equal to 5%. You obtain a sample of size n is equal to 226, in which there are 186 successful observations. For this test, you should not use the continuity correction, and you should use the normal distribution as an approximation for the binomial distribution. What is the test statistic for this sample? And then we're going to compute the p-value, and then we're going to determine whether the p-value is less than or greater than alpha, and from there we're going to come up with a decision. So let's start by finding the test statistic, which is z0. We know that z0 is equal to p hat minus p0 divided by the square root of p0 times 1 minus p0 divided by n. So I'm going to compute z0 right here, but before that I would like to come up with p hat because I don't have that. From the question I have x is equal to 186, which is the number of successful observations, and then the sample size is 226. p0 is the proportion from the null hypothesis, 0.76. Alpha is given 0.05, the level of significance. So p hat is equal to x divided by n. I'm going to compute that right here. X divided by n, so I click on the cells that have the numbers, and then I will compute z0 using the formula right here. The formula says, I'm going to open parentheses because Excel does not understand that it does subtraction first and then it divides. It will only divide the second number. So p hat is this number that I just computed minus p0, which is this number, and then divided by the square root sqrt of p0, which is this number, times, open parentheses, 1 minus p0, which is that number, and then divided by 226, which is that number, and then close parentheses and click enter. So that is the z statistic. I'm going to copy that and paste it to my answer box. And then I would like to find the p hat. The p hat is the area to the right and the left of z0, because I have a two-tailed test in this case. Let me draw that actually. So I know that this is the distribution that I'm talking about because we're using the normal distribution in this case. This is the distribution that I'm talking about. And here is z0. We will have, since we have two-tailed test in this case, we're talking about a two-tailed test. So we will have a z0 right here, which is going to be the negative one, and we will have z0, which is the positive one. P-value is the area in here and here. So both of those areas will be the p-value. If you add those areas, it will give you the p-value. Since we came up with the z0 and it was positive, then it is this z0 right here. To find the area to the left of z0, I'm going to use the formula norm, or the function norm dot s dot distribution of this number, but with a negative sign because I want this area. So I will go negative 2.21791, comma, true. And if I multiply this area by 2, then I'm computing the p-value because I have two areas that are similar in size because of the symmetrical properties of the normal distribution. So it is sufficient to come up with the area in one of those tails and then double that area to find the p-value. So I will go ahead and use this formula to compute the p-value. 2 times norm.distribution, norm.s.distribution of negative this number, comma, true. And that is the p-value. So I'm going to copy and paste the p-value. And next, I will make the decision based on the information that I have here. I know that the p-value is definitely less than alpha, because alpha is 5% and this is approximately 3%. So p-value is less than alpha. Since p-value is less than alpha, I know that we're going to reject the null hypothesis. So the right decision is to reject the null hypothesis. Let me explain actually the p-value approach. In the p-value approach, we find the area that represents the area to the left and right of Z0 if we're talking about two-tailed test, or to the right of Z0 if we're talking about a right-tailed test, or the left of Z0 when we talk about the left-tailed test. Let's say that we found p-value, and p-value in this case was less than alpha. Alpha is basically the area in the tail that is represented by the z-critical, or the boundaries for that area is the z-critical. So if we have a two-tailed test, we're going to have basically here a z-critical, and we're going to have another here, z-critical. And this is negative, that is positive. So if the area in both tails, which is the red area, is less than the blue area that I'm going to shade right now, then that means that the Z0 is going to be inside the critical region. And as a result, we're going to reject the null hypothesis. But if that is not the case and we have the blue area to be less than the green area, that means Z0, both of them are not going to be inside the critical region, the blue region. They are going to be outside in the white region. And as a result, we're not going to reject the null hypothesis or fail to reject the null hypothesis. And that is the main idea behind the p-value. We use areas here or probabilities instead of using numbers and comparing numbers. So in this case, when you use the p-value approach, you're not going to need to compute the z-critical. You're not going to compare numbers, but rather you're going to compare areas, or in other words, probabilities. So hopefully that clarified the p-value approach. Let me go back to the question and finish the rest. So the final conclusion will be, there is sufficient evidence to warrant rejection of the claim that the population proportion is not equal to 0.76. That is not right. We're not rejecting the alternative hypothesis. There is not sufficient evidence to warrant rejection of the claim that the proportion is not equal to 0.76. The sample data supports the claim that the population proportion is not equal to 0.76, or there is not sufficient sample evidence to support the claim that the population proportion is not equal to 0.76. Since we're rejecting the null hypothesis, this means we have enough evidence to support the alternative hypothesis claim. So the decision is the third one. I hope this video helped you, and I will see you in a different one.